Now I'm going to take the help of an example or a scenario to actually explain what is cryptography. Alright, so let's say we have a person and let's call him Andy. Now suppose Andy sends a message to his friend Sam who is on the other side of the world. Now obviously he wants this message to be private and nobody else should have access to the message. Now he uses a public forum, for example the internet, for sending this message. The goal is to actually secure this communication, and of course we have to be secure against someone. Now let's say there is a smart guy called Eve who has secretly got access to your communication channel. Since this guy has access to your communication, he can do much more than just eavesdrop. For example, he can try to change the message in itself. Now this is just a small example. What if Eve actually gets access to your private information? Well, that could actually result in a big catastrophe. So how can Andy be sure that nobody in the middle could access the message sent to Sam? The goal here is to make communication secure, and that's where cryptography comes in. So what exactly is cryptography? Well, cryptography is the practice and the study of techniques for securing communication and data in the presence of adversaries. So let me take a moment to explain how that actually happens. Well, first of all, we have a message. This message is firstly converted into a numeric form, and then this numeric form is applied with a key called an encryption key, and this encryption key is used in an encryption algorithm. So once the numeric message and the encryption key has been applied in an encryption algorithm, what we get is called a ciphertext. Now this ciphertext is sent over the network to the other side of the world, where the other person who the message is intended for will actually use a decryption key and use the ciphertext as a parameter of a decryption algorithm, and then he'll get what we actually sent as a message. And if some error had actually occurred, he'd get an error. So let's see how cryptography can help secure the connection between Andy and Sam. So to protect his message, Andy first converts his readable message to an unreadable form. Here he converts the message to some random numbers, and after that he uses a key to encrypt his message. After applying this key to the numerical form of his message, he gets a new value. In cryptography, we call this ciphertext. So now if Andy sends the ciphertext or encrypted message over communication channel, he won't have to worry about somebody in the middle of discovering the private message. Even if somebody manages to discover the message, he won't be able to decrypt the message without having a proper key to unlock this message. So suppose Eve here discovers the message and he somehow manages to tamper with the message and message finally reaches Sam. Sam would need a key to decrypt the message to recover the original plaintext. So using the key, he would convert a ciphertext to numerical value corresponding to the plaintext. Now after using the key for decryption, what will come out is the original plaintext message or an error. Now this error is very important. It is the way Sam knows that message sent by Andy is not the same as the message that he received. So the error in a sense tells us that Eve has tampered with the message. Now the important thing to note here is that in modern cryptography, the security of the system purely relies on keeping the encryption and decryption keys secret. Based on the type of keys and encryption algorithms, cryptography is classified under the following categories. Now cryptography is broadly classified under two categories, namely symmetric key cryptography and asymmetric key cryptography, popularly also known as public key cryptography. Now symmetric key cryptography is further classified as classical cryptography and modern cryptography. Further drilling down, classical cryptography is divided into two, which is transposition cipher and substitution cipher. On the other hand, modern cryptography is divided into stream cipher and block cipher. In the upcoming slides, I'll broadly explain all these types of cryptography. So let's start with symmetric key cryptography first. So symmetric key algorithms are algorithms for cryptography that use the same cryptographic keys for both encryption of plaintext and decryption of ciphertext. The keys may be identical, or there may be some simple transformation to go between the two keys. The keys in practice represent a shared secret between two or more parties that can be used to maintain a private information link. This requirement that both parties have access to the secret key is one of the main drawbacks of symmetric key encryption in comparison to public key encryption, also known as asymmetric key encryption. Now, symmetric key cryptography is sometimes also called secret key cryptography, and the most popular symmetric key system is the Data Encryption Standards, which also stands for DES. Next up, we're going to discuss transposition cipher. So, in cryptography, a transposition cipher is a method of encryption by which the positions held by units of plain text, which are commonly characters or groups of characters, are shifted according to a regular system, so that the ciphertext constitutes a permutation of the plaintext. That is, the order of units is changed, the plaintext is reordered. Now, mathematically speaking, a bijective function is used on the character's position to encrypt and an inverse function to decrypt. So as you can see that there is an example on the slide. So on the plaintext side, we have a message which says meet me after the party. Now this has been carefully arranged in the encryption matrix, which has been divided into 6 rows and the columns. So next we have a key, which is basically 421635, and then we rearrange by looking at the plaintext matrix, and then we get the ciphertext, which basically is some unreadable gibberish at this moment. So that's how this whole algorithm works. On the other hand, when the ciphertext is being converted into the plaintext, the plaintext matrix is going to be referred, and it can be done very easily. Moving on, we are going to discuss substitution cipher. So substitution of single letters separately, simple substitution can be demonstrated by writing out the alphabets in some order to represent the substitution. This is termed a substitution alphabet. The cipher alphabet may be shifted or reversed, creating the Caesar and Upstash cipher respectively, or scrambled in a more complex fashion, in which case it is called a mixed alphabet or deranged alphabet. Traditionally, mixed alphabets may be created by first writing out keyword, removing repeated letters in it, then writing all the remaining letters in the alphabet in the usual order. Now consider this example shown on the slide. Using the system we just discussed, the keyword zebras gives us the following alphabets from the plaintext alphabet, which is A to Z. So the ciphertext alphabet is basically zebras, then followed by all the alphabets we have missed out in the zebra word. So as you guys can see, it's zebras followed by S, C, D, F, G, H, and so on. Now suppose we were to actually encrypt a message using this code. So as you guys can see on the screen, I've shown you an example, which is a message, flee at once, we are discovered, is being actually encrypted using this code. So if you guys can see out here, the F letter actually corresponds to S, and then the L letter actually corresponds to I out here. Then we actually get the ciphertext, which is SIAAZQ, using the code and the process that I just discussed. Now, traditionally, the ciphertext is written out in blocks of fixed length, omitting punctuations and spaces. This is done to help avoid transmission errors to disguise the word boundaries from the plaintext. Now, these blocks are called groups, and sometimes a group count, that is the number of groups, is given as an additional check. Now, 5-letter groups are traditional. As you guys can see that we have also divided our ciphertext into groups of 5, and this dates back to when messages were actually used to be transmitted by telegraph. Now, if the length of the message happens not to be divisible by 5, it may be padded at the end with nulls, and these can be any characters that can be decrypted to obvious nonsense, so the receiver can easily spot them and discard them. Next on our list is stream cipher. So a stream cipher is a method of encrypting text to produce ciphertext in which a cryptographic key and algorithm are applied to each binary digit in a data stream 1 bit at a time. This method is not much used in modern cryptography. The main alternative method is block cipher, in which a key and algorithm are applied to block of data rather than individual bits in a stream. Okay, so now that we've spoken about block cipher, let's go and actually explain what block cipher does. A block cipher is an encryption method that applies a deterministic algorithm to the symmetric key to encrypt a block of text rather than encrypting 1 bit at a time as in stream ciphers. For example, a common block cipher, AES, encrypts 128-bit blocks with a key of predetermined length that is either 128, 192, or 256 bits in length. Now, block ciphers are pseudo-random permutation families that operate on the fixed size of block of bits. These PRPs are functions that cannot be differentiated from completely random permutation and thus are considered reliable until proven to be unreliable by some source. Okay, so now it's time that we discuss some asymmetric cryptography. So, asymmetric cryptography, also known as public key cryptography, is any cryptographic system that uses pair of keys, which is a public key which may be disseminated widely, and private keys which are known only to the owner. This accomplishes 2 functions: authentication, where the public key verifies that a holder of the paired private key sent the message, and encryption, where only the paired private key holder can decrypt the message encrypted with the public key. In a public key encryption system, any person can encrypt a message using the receiver's public key. That encrypted message can only be decrypted with the receiver's private key. So to be practical, the generation of public and private key pair must be computationally economical. The strength of a public key cryptographic system relies on computational efforts required to find the private key from its paired public key. So effective security only requires keeping the private key private, and the public key can be openly distributed without compromising security. Okay, so now that I've actually shown you guys how cryptography actually works and how the different classifications are actually applied, let's go and do something interesting. So you guys are actually watching this video on YouTube right now. So if you guys actually go and click on the secure part besides the URL, you can actually go and view the digital certificates that are actually used out here. So click on certificates and you'll see the details in the details tab. Now, as you guys can see, the signature algorithm that is used for actually securing YouTube is being SHA-256 with RSA. And RSA is a very, very common encryption algorithm that is used throughout the internet. Then the signature hash algorithm that is being used is SHA-256. And the issuer is Google Internet Authority. And you can get a lot of information about sites and all their authority key identifiers, their certificate policies, the key usage, and a lot of things about security just from this small little button out here. Also, let me show you a little how public key encryption actually works. So on the site, which is basically cobwebs.cs.uga.edu, you can actually demo out public key encryption. So suppose we had to send a message. First, we would need to generate keys. So as you can see, I just click generate keys and it got me two keys, which is one is the public key, which I will distribute throughout the network, and one the private key, which I will actually keep secret to myself. Now I want to send a message saying, hi there, when is the exam tomorrow? So now we are going to encrypt it using the public key because that's exactly what's distributed. So now as you can see, we have got our ciphertext. So this huge thing right out here is ciphertext, and it absolutely makes no sense whatsoever. Now, suppose we were to actually then decrypt the message. We would use the private key that goes along with our account, and we would decode the message. And as you guys can see, voila, we have hi there, when is the exam tomorrow? So we have actually sent a message on the internet in a very secure fashion. Above that, there's also RSA that needs some explaining because I had promised that too. Now, RSA is a very, very commonly used algorithm that is used throughout the internet, and you just saw it being used by YouTube. So it has to be common. So RSA has a very unique way of applying this algorithm. There are many actual parameters that you actually need to study. Okay, so now we're actually going to discuss RSA, which is a very popular algorithm that is used throughout the internet. And you also saw that it's being used by YouTube right now. So this crypto system is one of the initial system. It remains the most employed crypto system even today, and the system was invented by three scholars, which is Ron Rivest, Adi Shamir, and Len Adelman. Hence the name RSA. And we will see the two aspects of the RSA crypto system. Firstly, generation of key pair, and secondly, encryption-decryption algorithms. So each person or a party who desires to participate in communication using encryption needs to generate a pair of keys, namely public key and private key. So the process followed in the generation of keys is as follows. First, we have to actually calculate n. Now, n is actually given by multiplying p and q, as you guys can see out here. So p and q are supposed to be very large prime numbers. So out here, p will be 35, but for some very strong encryption, we are going to choose very large prime numbers. Then we actually have to calculate phi. Now, phi, as you can see, the formula goes is p minus 1 into q minus 1. And this helps us determine for the encryption algorithm. Now, then we have to actually calculate E. Now, E must be greater than 1 and less than phi, which is p minus 1 into q minus 1. And there must be no common factors for E and phi except for 1. So in other words, they must be co-prime to each other. Now, to form the public key, the pair of numbers n and E form the RSA public key system. This is actually made public and is distributed throughout the network. Interestingly though, n is a part of the public key, and the difficulty in factorizing a large prime number ensures that the attacker cannot find in finite time the two primes, that is p and q, that is used to obtain n. This actually ensures the strength of RSA. Now, in the generation of the private key d is calculated from p, q, and e. For given n and e, there is a unique number d. Now, the number d is the inverse of e modulo phi. This means that d is a number less than phi such that when multiplied by e, it gives 1. So let's go and actually fill up these numbers. So N should be 35 out here. And if we generate them, we get the value of 5, which is 24, which is basically 4 into 6. And then we should also get E. So now E should be co-prime, so we are going to give it 11, as 11 is co-prime to both. So now for the actual encryption part, we have to put in E and N out here. So E out here for us is 11 and N is 35. And then we're going to pick a letter to actually cipher, which is A. And then we're going to encode it as a number. So as you guys can see, we've encoded it as 1. And out here, now after we've given the message its numerical form, we click on encryption and we get it. Now to actually decrypt the message, we are going to need D and N. Now D for us was 5 and N was 35. So 5 and 35. And then we're going to take encrypted message from above and we're going to decrypt this message. So after you decrypt it, we have the numerical form of the plain text, and to then decode the message, just click here, decode message, and as you guys can see, we have decoded a message using RSA. So guys, that's how RSA works. I explained all the factors that we actually use in RSA, from N to 5 to E to D, and I hope you understood a part of it. If y'all are still more interested, y'all can actually research a lot on RSA. It's a very in-depth cryptographic system. So when you get hired as a penetration tester or a security analyst, one of your main roles is vulnerability assessment. So what exactly is vulnerability assessment? Well, a vulnerability assessment is the process of defining, identifying, classifying, and prioritizing vulnerabilities in a computer system, application, and network infrastructures, and providing organization doing the assessment with the necessary knowledge, awareness, and risk background to understand the threats to its environment and react appropriately to them. So vulnerability is a situation that can be taken advantage of by a hacker or a penetration tester for their own misuse or actually for fixing the issue. So vulnerability assessment has 3 steps. So the first step is actually identifying the assets and the vulnerabilities of the system. The second step is actually quantifying the assessment. And the third is reporting the results. Now, vulnerability assessment is only a small part, and pen testing is an extended process of vulnerability assessment. Pen testing or penetration testing includes processes like scanning, vulnerability assessment in itself, exploitation research, and reporting whatever the results are. So, in the industry, one of the most widely used frameworks when penetration testing is Metasploit. So, Metasploit is widely used in penetration testing, as I just said, and also used for exploitation research. So, some of you might ask, what exactly is an exploit research? Well, in this world, there are tons of exploits, and the way to approach each one of them is ever so different. So, what we have to do is exploit all the research that is available to us, and we have to find the best way to approach them. So, suppose, for example, you have a secure shell login. So, the best way to actually approach a secure shell login, until my knowledge, is that you have to get a backdoor access to this from the port numbers that you can scan via Nmap or Zenmap. Okay, so without wasting much time at looking at PowerPoint presentations, let's actually get started as to how we can use Metasploit. So Metasploit is a freely available open source framework that is widely used by pen testers, as we just discussed. So to actually install Metasploit, which is easily available on Linux and Windows, I guess. Let me just check it out. So you go on your browser and you type Metasploit downloads. Now you just visit the first link, and as you guys can see, it says it's the world's most used penetration testing tool. And then you just download the Metasploit framework by clicking the download button here. So y'all might also find a pro version, which is a paid thing. And this has a little bit of extra features like group support and actually helping a company work as an organization. But we don't actually need that when practicing our pen testing abilities. So for that, you just go ahead and download Metasploit framework and install it on your system. Above that, there's another thing I want to make you guys aware of, and that is Metasploitable. So when actually pen testing, we need a server or a website to actually pen test things on. So normally this is a very illegal thing to do without permission. So Metasploitable has actually created a server with a lot of vulnerabilities on it, and it's called Metasploitable 2. So Metasploitable 2 is easily downloadable from this link, and it's a VirtualBox file, so you guys must have a virtual machine software on your system to actually set this thing up. I'll also go through how to actually set up Metasploitable because it has a lot of configuration and network management to go with it. So we'll get to that later. But for now, let's get started with Metasploitable. So before that, Metasploitable is written in Ruby. And if you all know Ruby coding and you all know how to make exploits, you all can also always contribute to the Metasploit community. So Metasploit is one of the most widely used pen testing tools in the industry. So what exactly is Metasploit? Well, it's a framework, and what a framework is it's actually a collection of tools. So these tools are majorly used for penetration testing and exploitation research. Now one might ask, what exactly is exploit research? Well, there are tons of exploits out there, and there are tons of ways to actually approach them. And this only comes to us from thorough research as to how we can approach each and every exploit in their best way. So talking about Metasploit, well, it's open source and it's free, and it's also written in Ruby. So if you guys know Ruby coding and know how to make exploits, y'all can always contribute to the Metasploit framework. Now talking about the download part, well, y'all can easily download Metasploit from its download page, which is www.metasploit.com/download. I'll be leaving the download link in the description. And once you're on the download page, you'll see two versions. One is the free version, which is the original Metasploit framework, and it's the core framework that everybody works on. And then there's Metasploit Pro, which comes with a 14-day free trial. So Metasploit Pro actually has a few extra features, which is great for an organization. Like it helps you work as a team. But if you're a guy who's just practicing pen testing like me, Metasploit framework, the free version, is the absolute way to go. Now also, when pen testing, y'all will also need Metasploitable. Now Metasploitable is an intentionally vulnerable target machine for actually practicing your Metasploit skills on. So we'll go over the installation of Metasploitable later, but for now, let's go over Metasploitable. So once you guys have actually downloaded the link, y'all can actually install it on your systems. And Metasploit actually has three interfaces. So we are going to be using the command line interface, or the MSF console in other words, but y'all can also use the GUI interface, which is called Armitage if I'm not wrong. So let's get started. So first of all, I've already actually downloaded Metasploit and installed it on my computer. And y'all can just do the same by pressing the download button, as you guys can see. So to start up Metasploit, all you have to do is go on your terminal. And so to start a Metasploit, all you have to do is go on your terminal on Linux. Well, we're starting a PostgreSQL server because first of all, the PostgreSQL server is the basis of all the Metasploit exploits that are stored, and starting it will just make it run faster. So we go service PostgreSQL and start. So that should start up a service, and indeed it has. So next thing you want to do is go in and type msf console. And that's going to take a little bit of time because I have a very slow computer, and it's going to start up our Metasploit frame. So as you guys can see, we got a big banner out here which says Metasploit Cyber Missile, and the banner changes every time. Don't get worried if you have a different banner. And the main thing is that you should see this MSF thing out here. So this means we are in the MSF shell right now, which is the Metasploit framework shell. So let's get started by actually clearing our screen. So first things first, the first command that you might want to run on Metasploit is the help command. So help will tell us everything that we can do with this framework. So as you guys can see, there are a bunch of commands and the descriptions to go along with it. Y'all can give it a quick read and find the things that are interesting to you. So as you guys can see, banner is display an awesome Metasploit banner. Y'all can change the banner. As you guys can see, there are a lot of juicy commands, like there's a banner command which I just had used. So if you go and type banner, it'll give you a nice cool banner about Metasploit. And there are other commands which work very similar to Linux, like cd, which changes the current directory. You can change the color by toggling colors. And then you can connect with a host and all sorts of stuff. So Metasploit has a bunch of exploits. So before we go further, I want to make you guys aware of three important terms regarding Metasploit. So the first is a vulnerability. And we had already discussed this, that a vulnerability is a situation which can be taken advantage of by a system or a person who access. So the second part is an exploit. So what exactly is an exploit? Well, an exploit is a module, which is a bunch of code written in Ruby on Metasploit that is used to target different vulnerabilities. And the third thing is a payload. So a payload is the action that you do once you actually have access to somebody's system. So basically, suppose you've hacked somebody and you've gained access to their system. Now the activities you do after gaining access is defined as the payload. So we just spoke about exploits, and I told you guys that Metasploit has a bunch of exploits. So how do we see all the exploits that are there? So you go show exploits. Well, as you guys can see, we've loaded up a bunch of exploits, which is basically all the exploits that Metasploit has to offer at this moment. So let me just increase the screen a bit. And let's scroll completely to the top. Yep. So as you guys can see, show exploits gave us a bunch of exploits, and it shows their name, a description, a disclosure date, and a rank. So the name and description is as it says, it's the name of the exploit and it's a short description about it. The disclosure date is when the exploit was actually released by Metasploit, and the rank is how it has fared against the vulnerability it was released for since it was actually released. So as you guys can see, ranks range from excellent, great, good, and stuff. And we have a bunch of exploits. So as you guys can see, there's an Android exploit, there's a Samsung Galaxy Knox Android exploit, there are a bunch of Windows exploit, Adobe Flash exploits, FTP exploits, MySQL exploits, ASP.NET exploits, and a bunch of other stuff. So as you guys can see, there are a bunch of exploits to use, and it can get confusing and rather troublesome to search for the exploit you actually want to use. So as a pen tester, you can always go for the search keyword, which is basically suppose you know that you have a MySQL server which has a bunch of vulnerabilities and you want to test those out. So you simply go search MySQL. Now I'll search the database for all the exploits that are related to MySQL and present them to you. Okay, so we have our results. So as you guys can see, we have a bunch of MySQL related modules now. Now, this makes it way easier if you're a pen tester and you're looking for MySQL exploits. Now, suppose you choose your exploit and let's see. Let's choose which one do we want to use today. We're going to just use this MySQL hash dump. So to actually use this, we have to copy the name. So double click on it and it'll just select it, and then you go Control Shift C in your terminal. So that copies it. And so if you want some more information about it, you can always go info and then just paste in the name of the exploit. So this gives us a bunch of information, actually gives us all the information you need about the exploit. So it gives you the name, that it's a MySQL password hash dump. Its module name is auxiliary scanner and all this stuff. It's licensed by Metasploit framework in itself, and it has a normal rank. And these are all the options that you might need to set when actually using the exploit. And this also gives you a small description. So it says this module extracts the usernames and encrypted password hashes from a MySQL server and stores them for later cracking. So seems like pretty cool stuff you can do with MySQL server and its password database. So if you actually want to use this, so you have to use the use keyword. So we go use and Control Shift V. So as you guys can see, it's denoted in red out here that we are indeed in the exploit that we want to use. Now, the first thing you want to do when you're using an exploit is you want to go and say show options. Now, as you guys can see, these are the options that we actually need to set before using the exploit. Now, the options can be necessary or they can be optional. So there's a password field out here, which is not really necessary, but will help your exploit if you actually provide it. But you need to provide the R hosts, which is the targeting host machine, and the port and the threads is already set. Now, suppose you want to set the R hosts, so you can just go set R hosts and you can set it to whatever IP address you want. Like suppose you want to address 192.168.2.56, something like that. So then that will set the R hosts. You can also set the number of threads, Now, threads are actually what the threads mean in parallel processing. That means how many parallel threads you're going to run so that you have faster computation. So this means you need GPU power if you have multiple threads running. So let's set threads to 30 for now. So we've set the threads to 30, and then you can go show options again and see that you have indeed actually set your options. So we've set the threads to 30 and our host has also been set. So that was all about how you can get into a module, get some information about a module, and how you can also use the module. So once you're done using the module, or once you're done setting up the options rather, you can go ahead and run the command run or even exploit. And this will start actually running the exploit on the system that you want to. Now I've put in a very arbitrary IP address and that does not have MySQL port running, so our exploit failed. Now, once you have tested out your exploit and you want to go back to the main MSF Unix shell, just go ahead and type back. It's as simple as that. So that brings us back to the MSF command line. So let's go ahead and clear our screen now. Okay, so it's time we do something interesting. So to do that, first of all, we need to go ahead and actually download Metasploitable 2. So to download Metasploitable 2, you have to go on this link. I'll leave the link in the description. So, or rather, you can just go on your browser and type in Metasploitable 2 download. So Metasploitable, as we had earlier discussed, is a Linux-based distribution, and it's mostly meant for actually practicing your pen testing skills. So basically, it has a bunch of ports open on it. So it's basically just for your ease so that you don't go ahead and test it out on some valid website and then get thrown into jail, because that's a very illegal thing to do. So go ahead and download Metasploitable 2 and then also download Oracle VirtualBox Machine or Oracle VirtualBox. So you all can also easily download that from www.virtualbox.org. And this is because you should never run Metasploitable 2 on a system that is connected to a network. You should always use it on a virtual machine because it's protected that way so that nobody else can access it. So to actually set up Metasploitable, once you've downloaded it, you go ahead and open up your VirtualBox. So out here, you have to go into Global Tools and you create a host-only network manager. Now I've already created a host-only network manager, and then you go ahead and enable the DHCP server by pressing this out here like enable. Then you go back and you just go new. You give it a name like whatever you want to name it. I have already named mine Metasploitable 2, as you guys can see. So we're going to call this demo for just demonstration purposes. Choose the type to be Linux, and it's a 1 to 64-bit. Click next, give it a gig of RAM, and you are going to use an existing virtual hard disk. So out here, you just click on this button out here, and you browse to the place where you've actually downloaded and unzipped your Metasploitable download file. Then you'll get this virtual machine disk file, which is a VMDK file, and you just go ahead and load it up. So I'm not going to do that again because that's just going to eat up my RAM, and I've already installed it out here. So that was all about the installation and the configuration. So now let's get started and let's start playing around with Metasploitable. So once you're done downloading and installing Metasploitable on your computer, all you have to do is go ahead and start it up in your VirtualBox machine. And the login ID and the password both are MSF admin. So first of all, we need the IP address of our Metasploitable server. So we go ifconfig, and this gives us the address. So as we can see out here, our address is 192.168.56.101. So once you go ahead and start up Metasploitable, it's time that we go ahead and exploit all the vulnerabilities that is presented to us by Metasploitable 2. So to do that, let's head back to our Linux terminal again. So once we have the IP address, that was 192.168.56.101 if I am correct. So let's go and quickly get a little bit of information about that. So who is 192.168.56.101? So this will give us a who is on Metasploitable 2, and it'll give us a bunch of information as to how the server is set up, where it is set up, the ports that are open, and various other things. So as you guys can see, this gave us a complete who is. So to get some more information about our Metasploitable server, we're going to be using Nmap. Now, if you guys don't know about how to use Nmap, you can go out and check my other video on the playlist. I've made a pretty good Nmap tutorial. So we go Nmap -f -s and v, which is steel version, and we give it the name or the domain name server, 92.168.56.101. So we've got a juicy result out here, and we can see that there's a bunch of stuff open. So as you guys can see, there's the FTP port open, which has a version of VSF TPD 2.3.4. There's also Open SSH, which is 4.7 P1 Debian. There's also Telnet, which is almost miserable to have Telnet running on your computer. Then there's SMTP, there's HTTP, and there's a bunch of ports open, as you guys can just see on your screen. So it's time we actually use Metasploit like a pen tester to go ahead and test out these vulnerabilities. So let's choose these FTP things. So we have this FTP out here. So from the version number, which is given to us by the steel version flag on Nmap, we know that it's using VSF TPD 2.3.4. So we can easily search for an exploit of the same version. So as a pen tester, you would go search VSF TPD 2.3.4. So this should give us all the exploits that are available for this particular vulnerability. So as you guys can see, after a long search from the search VSF TPD, we found a vulnerability or an exploit that can take advantage of the vulnerability. So it's time we actually use this. So first of all, let's get some info about this. So info, let's copy down this thing, and then let's get some info about this. So as this module description says, this module exploits a malicious backdoor that was added to VSF TPD download archive. This backdoor was introduced in the VSF TPD 2.3.4 tar.gz archive between June 30th and Walla Walla. So we have the options of setting an R host. It has an available target. It's provided by these guys, and it's a pretty good exploit in my opinion. So let's go ahead and use it. So we go use and the name of the exploit. So it's visible to us that we've again entered the exploit module, which is Unix/FTP/VSF-TPD234 backdoor. So what we're going to do is we are going to actually gain a backdoor access to our Metasploitable system. So to actually make this more believable, so if you guys go into your Metasploitable system, so you guys can see that you're in the root directory. So you can gain some root access by going sudo su and going msf admin. So we're now a root user in the msf admin, or rather the Metasploitable console. So if we go ls, we can see the various files. And if we go /home, we're in the home directory now. And if we do ls out here, we can see that there are a bunch of stuff. So there's an FTP folder, there's a hacked folder, there's an MSF admin folder, and there's service and there's user. So that's 5 folders if you guys remember. So now what we're going to do is we're going to gain some backdoor access into the system, and we're going to create a bunch of folders in the home directory. So let's get on doing that. So to do that, we head back to our Metasploit terminal, and we go show options as we had already entered our exploit. So go show options. So as we see, the options that we have to provide is the R host and the port number. Now the port number has already been set because it's 21, and that's where FTP runs, or rather TCP runs, and we now just have to set the host. So to set the host, we have to just put in the IP address of our Metasploitable server. So if I remember correctly, it's set our hosts to 192.168.56.101. So that has set our hosts. So we can again check that if we've done it correctly by going show options. And we indeed have set our hosts. Now all we have to do is run the exploit. So we go and hit run. So as you guys can see, we have actually gained a backdoor service has spawned and it's handling, and the command shell session has started. Now you might be confused as to why do I have this blinking line? Well, this blinking line actually means that you are inside the Metasploitable server. That means we have already gained a backdoor access, and this blinking line denotes that we are on the terminal of Metasploitable 2. Now, if you guys don't believe me, let's do some experimenting. So as I had said, I'll create a bunch of folders in the home directory. So let's change to the home directory first. Or rather, first you can also do a who am I, and instead you that you're the root user. Next, you go and do cd/home, and I'll change to the home directory. Now, let's make a bunch of folders, like make directory, this is a test. So that should have made a directory. So let's go into that directory, cd, this is a test. So we're already into the directory, this is a test. Now let's make a file called targets.txt. So that creates a file. So just to see if you have actually done it properly, let's go back to our Metasploitable server. Now in the home directory, you go and type in ls again. Okay, so let's type in ls and see. So as you guys can see, we have created a this is a test folder, and it's already available there. So let's go and move into that folder. So this is a test, and we are already in that folder. So, and we had also created a text file, which was called targets. So that was ls, and it should give us a targets.txt. So as you guys just saw, we gained a backdoor access into a remote system through a vulnerability that was available to us on the FTP port. So we first did that by scanning the entire domain name server of Metasploitable via Nmap and gaining some intelligence as to what ports are running and what ports are actually open. Then we found out that the FTP port was open. Then we went on to Metasploit and we found out exploit that vulnerability very successfully. We found out how to use the exploit, some information about that exploit, and in the end, we actually executed our commands.
Now, you guys must be wondering what exactly is Nmap and why should I learn it? Well, Nmap is a network scanner that is widely used by ethical hackers to scan networks, as the name suggests. Now, you might wonder, why do I need a network scanner? Well, let me give you an example. So, suppose you have a Wi-Fi that has been set up in your new house, and you realize that your data is being actually consumed at a faster rate than you are using it. Now, you have suspected that it's your pesky neighbor who keeps on connecting to your Wi-Fi and eating up all your data. So to actually confirm all your doubts, what you want to do is a network scan, and Nmap is a pretty wonderful tool to do that. Now, Nmap runs on Linux, Mac OS and Windows, and I'm mostly going to be running this on Linux because that's what I do most of my penetration testing and network testing on. So let's go ahead and get on with the installation of Nmap on your computer. So what you do is go apt-get install Nmap. Now for this you have to be logged in as root. If you're not logged in as root, just add sudo before this whole command and it will install it. Now I already have Nmap installed, so I'm not really going to install it again and again. So let's just go ahead and just do a few scans on our website, that is www.edureka.co, and we are going to see what we get back as results. So first of all, let me just show you how you can scan a certain domain name service or DNS. So Nmap, we are going to use a flag all the time. Now let me just tell you what are flags. So if you just go into Nmap and type --help, this will give you all the flags and options that are available to actually use on Nmap. So if you are actually stuck and you can't remember stuff, just go in and type nmap --help and it will give you all the stuff. Now, network scans generally take a long time, so I'm going to be using the fast mode most of the time. So for fast mode, all you have to do is type in edureka.co and sit and wait for this scan to get over. Now when the scan gets over, you will see a bunch of information, and let me just wait till that information pops up and then we'll talk about that information together. Okay, so as you guys can see, our scan has been completed. It took 13.71 seconds to actually do the scan. Now as you guys can see, it shows us the ports, the states and the services. Now the ports is basically the port number which our service, that is also binded to, is working on. So we can see that SSH service is working on port number 22, SMTP on 25, HTTP on 80, RPC bind on 111 and HTTPS on 443. So that is how you can use Nmap to scan a certain website. Now if you see, Nmap has also given us the public IP of the DNS, because what Nmap does is it looks up the DNS and then translates it to an IP that is recognized to the DNS server. So Nmap also returns the public IP. So what we can do also is Nmap -f and 34.210.230 and .35. Okay, so as you guys can see that our command also works when we put in the IP address and it produces the same results. Now we can also scan for multiple hosts. Now suppose you are on a network and you want to scan for multiple hosts. Now you don't really want to run different commands for that. Now what you can do is just go in and type nmap and a bunch of IP addresses like 192.168.1.1 and 192.168.1.2 and 192.168.1.3. And what this will do is it will run an nmap scan on these three different IP addresses, and you did this in just one command. So that's a way that you can do this. Now you can also know about how much of your scan is left by just pressing the up button. So that will tell you and give you a constant update on how your scan is going. Like mine is 32.4% done and 34.7 now, and also show you kind of the time remaining. Okay, so till this port scan is going on, let me just tell you about the states. Now states can be of two types: open, closed, and unavailable. Sometimes you'll see that it is unavailable, and that's because some sort of firewall or something is running out there. States can also be closed. In that case, mostly Nmap will not return you any result unless you're explicitly finding something of the closed state. So that was a little trivia on states and how they work. Let's see how much our scan is done. So our scan is done 81% and it takes around another 20 seconds. It should be done soon. Now this scan could be significantly made faster with just the F tag, but I really want to give you all a good look into how this works. 97, 98, 99. Okay, so as you guys can see, this is our result. It gives us a bunch of ports and services. Now, as I just said, this thing can be also closed and also unavailable. So open and closed, we see both the examples. Okay, so that was about how you can scan multiple ports. So you can also scan multiple ports with this command, as I will show you. So 192.168.1.1 to 30. Now what this will do is basically scan everything from 192.168.1.1 to 192.168.1.2 up till 30, like that. So this is a very useful way of actually scanning multiple IP addresses, and let me just show you how that works. Since we have used the F flag, this is going to work considerably faster. Now as you guys can see out here, this had taken around 119 seconds, so that's around 2 minutes. Now this will take a considerably lesser time. So let's see, this was done in 29.91 seconds and we did 30 IP addresses. So we see that -F surely speedens the whole scanning process. Now you can also give Nmap a target list. Now let me make a target list. So targets.txt. Let me just cat it out for you. So there's nothing in it. Now all I want to do is edit this file. So let me just edit that file and put in 192.168.1.1, 192.168.1.2, 192.168.1.3, 192.168.1.4, 192.168.1.5, or 15. Boom, roasted. Now all we have to do is save it. So that saves it, and Control X to actually exit it. Now you can go ahead and view what is in targets.txt. So as you guys can see, this is what is in targets.txt. And now you can just pass it to Nmap with the IL flag, and you could say that Nmap is going to actually scan all the IP addresses that are in this file. So let that just run. So this will take a little bit of time because it's 5 IP addresses and it's not really running on the fast mode. 83% of our work is done. Okay, so as we see, our scan has been completed. Now what you see out here is the scan results for whatever we had provided in the targets.txt list. So that's how you can also provide Nmap input file, and it will give you the results for all the targets that were specified in the file. Now let's go ahead and talk about a little bit on port scanning. So Nmap is also a brilliant tool for scanning ports. And if you have a server or a website, you know that there are around 65,535 ports out there on every server. And almost 99% are unused. So sometimes scanning ports is really a necessity. Now you can scan ports by just using the P flag and specifying the port number. And this is how you would do it. And you would just specify the IP address after that. So I'm going to use www.edureka.go. And what you can also do is this will scan only the port number 20, but you can also scan from port number 20 to 25. You can also put in commas and tell Nmap you also want to scan all these other port 80 is HTTP and 443 is HTTPS. So you can surely do that. So let me just go ahead and run this. Okay, so that gives us an information on the ports that is there. Now, something about ports also, you suppose you know you want to scan for some HTTP ports. So you can just say nmap and with the -p, you can just say that I want to scan the HTTP port on www.edureka.go. So that will just go ahead and do that. And as you guys can see, that gave us a result. And you can also add in stuff like MySQL, FTP, and stuff like that. So let me just see and show you how that runs. Okay, HTTP is not a port, HTTP. Okay, so as you guys can see, these are the ports that are running, and it gave us according to the name. Now, if you want to scan all the ports, you can use -p and then the IP address at www.edureka.go. Now, this generally takes a lot of time because you're basically doing 65,000 scans, so I'm not really going to do that. I'm going to quit this out. Another thing that I wanted to show you all that generally takes a lot of time to actually execute is called something like an aggressive scan. So as you guys can see out here, I have done an aggressive scan on Edureka. So to do that, all you have to do is nmap-a and then you go edureka.go. So let us see how much time did this take to actually execute. This took 459 seconds. That's a long time for a scan. But it gives us a bunch of other information. For example, it gives us the trace route. So what is a trace route first of all? So trace route is the route taken by a packet to actually reach the clients and the target server. So as you guys can see, our packet had 22 hops. First it went to the first hop was to the gateway router, that is 192.168.1.1. Then it went to the Airtel lease line, then it went to this IP address, then it went to the BSNL VSNL.net, and it went to London, New York, then Chicago, and it went all the way up to wherever this thing is hosted. That was some information, and then there is some other information given to us like the TCP open, TCP wrap, program versions, port types, port states, and all sorts of other information is given about in an aggressive scan. Another scan that I have previously also done and kept for y'all is because it takes a lot of time, and I have done something called the service version. So nmap-s and v with v capital will give you the service version. So it tries to actually guess the version of the service that is running. So for example, on the TCP port it tells us it is postfix SMTPD. On the Apache it's Apache HTTPD, and you can see all sorts of versions that are here. Another thing Nmap is generally brilliant is for guessing the operating system that is running. Now, I have already done this scan previously because this takes a humongous amount of time that I don't really have, and that is 386.34 seconds. And this scan together basically took me more than 10 minutes, and I don't really have that kind of time for explaining all this stuff. So, as you guys can see out here, the OS is kind of, OS details is Fortinet, FortiGate. It kind of tries to guess the OS upon the time to live that is in the response from the packets that it sends. So, -SV, -O, and -A are some really cool stuff that you might want to know. Another thing that you can do is traceroute, as I had just told y'all, and y'all can do traceroute separately. So you go --traceroute, and then you say the name of any sort of website. So suppose I want to know how I reach netflix.com. So I go netflix.com, and this will give me a traceroute that shows me how my packet actually reaches netflix.com. Okay, so this is basically it was a direct one hop Okay, so that was surprising. On the other hand, if I were to do this on edureka.co, it would take a bunch of hops to actually reach there. Okay, this might just take some time to run. Okay, so it's 94% done. I'm just waiting for it to get completed. Okay, so this gave us the hop, and as you guys can see, we took 22 hops to actually reach edureka.co, and it's the same process. You go through a bunch of IP addresses, and then you reach this thing called US West to compute.amazon AWS. Okay, so that was about traceroute. Now, just to end this tutorial, let me just tell you guys that you all can also save a file to Nmap, and that is basically save all whatever you found from a search into a file, and let me just show you how to do that. Now, sometimes when you are working as a security analyst, you will have to perform network scans on a wide area network that is huge. It's basically huge. And these scans take a lot of time, and you don't really have the space on your command line to actually store that and see that in a way that is feasible for analysis. So what you want to do is actually save it in a file. So what you can do is say nmap on, and then you can say the name of the file. We could say results.txt, and we could save this in file. So www.edureka.co. So whatever search result is going to be generated is going to be stored in this file called results.txt. Now this file need not exist from before. It will just be created by nmap. And now you see if I do ls, we have a targets or a results.txt. Now if I just cat out that file, let me just less it actually. Results.txt. And what you see out here is an nmap scan result that is stored. Another thing that I would like to show you all before I end this Nmap tutorial is a verbose mode. So for verbose mode is basically when we were pressing up arrows to see how much of our scan is done, you can basically do that with verbose mode. So you go -F and -V for verbose, and you could say www.edureka.co. And this will basically give you a verbose mode of what is actually going on. It'll tell you everything, and boom, roasted, there it's done. And we have finished